Welcome to the DIY Honda Garage channel. This presentation focuses on the diagnostic trouble codes, or DTCs, P2096 and P2097, which signify issues with the fuel trim system in the Honda Accord 2023 and newer models. DTC P2096 indicates that the post-catalyst fuel trim system is too lean, while P2097 suggests it is too rich. These codes arise when the Powertrain Control Module, or PCM, detects deviations in the fuel trim, which is responsible for adjusting the air-fuel mixture for optimal engine performance and emissions control. The PCM continuously monitors the fuel trim adjustments by using various sensors throughout the exhaust and fuel systems. When the fuel trim adjustments exceed the limits defined in the vehicle's software, the PCM records the appropriate DTC error, prompting a need for troubleshooting. DTC P2096 indicates that the post-catalytic converter fuel trim system is too lean, which means there is not enough fuel coming into the system relative to the air being consumed. Conversely, DTC P2097 indicates a too rich condition where there is an excess of fuel. The main components involved in these codes include the air-fuel AF sensor 1, which measures the air-fuel ratio before it enters the catalytic converter, and the secondary heated oxygen sensor HO2S, which monitors emissions after the exhaust gases have passed through the converter. Both sensors are critical for the PCM to determine whether the engine is operating efficiently and within emission limits. The AF sensor is typically located on the exhaust manifold, while the secondary HO2S is positioned downstream, usually after the catalytic converter. Several possible causes can lead to the activation of DTCs P2096 and P2097. The first is a faulty AF sensor, sensor 1, which can become unresponsive or provide inaccurate readings about the air-fuel mixture. If this sensor isn't working correctly, it may cause the PCM to think the mixture is either too rich or too lean, triggering the DTCs. Another potential cause could be an exhaust leak occurring between the AF sensor 1 and the secondary HO2S. Such leaks can allow additional air to enter the exhaust stream, misleading both sensors into reporting incorrect values. Clogs or restrictions in the exhaust system may similarly result in abnormal readings from these sensors, thereby causing the PCM to register faults. Lastly, issues within the fuel system, such as improper fuel pressure or faulty injectors, can also contribute to these DTCs. Vehicles experiencing DTC P2096 and P2097 may present several noticeable symptoms. One common symptom is poor acceleration, where the vehicle may lag or feel sluggish. This happens due to incorrect fuel delivery and air ratio, resulting in inefficient combustion and loss of power. Increased exhaust emissions can also be a direct result. The vehicle may emit more pollutants due to imbalances in the air-fuel mixture. Typically, drivers will also notice a check engine light illuminating on the dashboard, prompting them to seek diagnostics. Additionally, rough idling or stalling could occur as the vehicle struggles with improper fuel trim adjustments, compelling the PCM to send signals for correction. The first step in troubleshooting DTC P2096 and P2097 involves starting the engine and holding the engine speed at 3,000 RPM without load, i.e., the vehicle should be in either park or neutral. This high RPM ensures that the engine reaches a stable operating temperature, allowing the Powertrain Control Module to read the response from various sensors accurately. Continually monitoring the engine until the radiator fan activates indicates that the engine has reached sufficient operating temperature. This step is crucial as it sets the baseline for the subsequent tests. Accurate readings from the components will follow, ensuring that any deviations can be traced back more effectively. In the second troubleshooting step, you must drive the vehicle at a steady speed within the range of 15 to 75 miles per hour for a duration of at least 67 seconds. This driving condition is essential for verifying that the emission control system is functioning correctly under real-world conditions. During this time, it's important to ensure that the engine coolant temperature (ECT) sensor 1 reads above 158 degrees Fahrenheit or 70 degrees Celsius. Verifying this temperature confirms that the engine and its components are operating within their designed parameters. Finally, it's crucial to monitor the onboard diagnostics (OBD) status using a Honda Diagnostic System (HDS) or similar tool to check for the presence of DTC P2096 and/or P2097. This will provide immediate feedback on whether the earlier adjustments have resolved the DTCs. The next step is to thoroughly inspect the exhaust system. A visual inspection is crucial here, where you will check for any signs of leakage between the AF sensor, sensor 1, and secondary HO2S, sensor 2. Such leaks can greatly affect sensor readings, leading to inaccurate DTCs. Additionally, it is important to identify any clogs or restrictions that could be present within the exhaust system. These obstructions can impede the normal flow of exhaust gases, leading to a back pressure that may affect the sensors as well. If any leaks, clogs, or restrictions are identified, they must be repaired before further diagnosing the DTCs. Ignoring these issues could lead to persistent faults that may not be resolved by sensor replacement alone. The final step involves inspecting AF sensor, sensor 1 for any faults. If previous tests have indicated that the other components in the system are functioning normally, the AF sensor may be the source of the problems. This sensor plays an essential role in measuring the air-fuel mixture before it reaches the catalytic converter. Functional testing of this sensor should be performed to ascertain whether it is providing accurate readings to the PCM. If found defective, the AF sensor should be replaced to restore proper functioning of the system. Ensuring that this component operates correctly can significantly help in resolving the issues leading to the DTCs being triggered. To conclude the troubleshooting and repair process for DTC P2096 and P2097, the final step is to clear the codes from the system using the Honda Diagnostic System HDS. Once the DTCs are cleared, it is essential to test drive the vehicle under the same conditions used earlier to verify that the issue has been resolved. As part of this process, you should monitor for any reoccurrence of the DTCs during the test drive. Successful completion of this step is an indicator that the system is functioning correctly and has resolved the air-fuel trim issues flagged previously. If the DTCs reappear, further investigation into other areas may be warranted to ensure lasting repairs. Preventive maintenance is crucial for avoiding the recurrence of DTC P2096 and P2097. Regular checks of the exhaust system should be carried out to identify leaks and clogs before they escalate into larger issues. Additionally, it is advisable to include routine inspections of the AF sensor and secondary HO2S as part of a regular maintenance schedule, ensuring they function correctly. Keeping an eye on the fuel system pressure can also play a significant role in maintaining optimal operation. By adhering to these preventive measures, you can prolong the life of the vehicle's emissions control system and optimize performance, effectively averting potential DTCs associated with fuel trim deviations. In summary, understanding DTC P2096 and P2097 is vital for ensuring the longevity and efficiency of the Honda Accord's engine performance and emissions control systems. These DTCs signify concerns with the post-catalyst fuel trim, which, if left unaddressed, could lead to increased emissions and reduced engine efficiency. Throughout this troubleshooting guide, we discuss the roles of the AF sensor and secondary HO2S, emphasizing their importance in measuring the air-fuel mixture accurately. Key troubleshooting steps were outlined to provide a structured approach for diagnosis and repair, from verifying engine conditions to inspecting critical components. Proper attention to both corrective actions and preventive maintenance will help in maintaining optimal vehicle performance, thereby enhancing driving experience and reducing environmental impact. Please like and subscribe to the channel. See you next time!